Hello everyone. Today we are going to start a new training session on security essentials. We are now on the first course, Networking Concepts. But before starting this course, we must understand why we need security, why security is important for us, why we are talking about security, cybersecurity, and why we are getting training on security essentials. We need physical security just as we need cybersecurity because we are connected with the internet and we are in our virtual worlds. Security here is becoming more important. In this training, you will get to know what are the networking concepts, what is cryptography, what is encryption, what is physical security according to cyber attacks. So now we are going to start our first course that is networking concepts. The objective of this course will be to, in class 1, to get to know about networking fundamentals, network types, network topologies, LAN protocols, WAN protocols, and network devices. In class 2, you will get packets and addresses, IP service ports, IP protocols, TCP, UDP, ICMP, and DNS. In class 3, we're going to go over TCP dump, recognizing and understanding UDP, ICMP. And in class 4, we're going to go over routers, routing protocols, access control protocols. And in class 5, we'll finish up with physical security threats, physical security controls, and physical security measures. So let's dive into class 1. Networking fundamentals. Networking fundamentals teaches computer science students the building blocks of modern network design, as we get the architecture of our network from which we are connected. In case you know all the topologies, all the networking devices, and all the networking fundamentals, then you will get to know how you are connected with the internet. What is the basic architecture from which you are connected? For example, if you are in a building and you know how many floors are in the building, where the gates are, where the windows are, then you know the architecture of that particular building. It's similar in the case of being connected to the internet and knowing all the networking fundamentals. So there are many different kinds of networks and network typologies and technologies used to create them. The proliferation of network methods has generally occurred for very good reasons. Different needs require different solutions. The drawback of this is that there are so many types of protocols and technologies for the networking student to understand. The network topologies and protocols are very wide. We have different kinds of networks. We have different kinds of protocols. So it's really tough for a student to get to know. Before you can really compare these approaches, you need to understand some of the basic characteristics that make networks what they are. So first is network types. Here I'm talking about LANs and WANs. So first, what is LAN? A LAN, or a local area network, is a group of computers and associated devices that share a common communication line or wireless link to a server. Typically, a LAN encompasses computers and peripherals connected to a server within a small geographic area such as an office building or a home. If someone is connected with a single line, maybe it's a broadband, maybe it's a wireless, that is called a local area network. It's a very small range network and it will be or it is in a particular office or a particular home or just a particular building. Computers and other mobile devices can share resources such as a printer or a network storage. They can share with each other because they are connected by the same network. A local area network may serve as few as 2 or 3 users in a home or office as many as hundreds or thousands of users. So a LAN is a group of computers or peripheral devices that are sharing a common communication line. That's the important aspect of a LAN. WANs, or a wide area network, are a geographically dispersed telecommunication network. LAN is in a particular building, home, or office, but WANs can connect multiple locations dispersed throughout a geography. A wide area network may be privately owned or rented and usefully connects the inclusion of public networks. This ensures that computer users in one location can communicate with computer users in another location. In LANs, users can communicate within a single building, and in WANs, they can communicate within multiple buildings across several locations. WANs are similar to a banking system where hundreds of branches in different cities are connected with each other in order to share their official data. Next, we'll be going over network topologies. A topology is usually a schematic description of the arrangement of a network, including its nodes and connecting lines. So the topologies show us how we are connected, how our systems and devices are connected with each other. Network topologies define the layout of the virtual structure of a network, not only physically, but also logically. The way in which different systems and nodes are connected and communicate with each other is determined by a topology of the network. Like we are in a ring topology or a tree topology, we'll discuss these in a bit. So topology will explain how devices are connected to a network. First, you have to understand what typology you're using. Maybe it's a ring topology, maybe it's a tree topology, maybe it's a star, or maybe it's a bus. So let's discuss these different topologies, like bus topology, star, ring, mesh, tree, and hybrid. First, we'll review the bus topology. A bus topology is a network type in which every computer and network device is connected to a single cable. When it has exactly two endpoints, then it's called the linear bus topology. Here you can see how it works. All the devices are connected with a single line. So in bus topology, when devices are connected in a single line with a single cable, you can say so that is called a bus topology. In the bus network topology, every workstation is connected to a main cable called the bus. Therefore, in fact, each workstation is directly connected to every other workstation in the network. Each topology has its own set of pros and cons. In the case of the bus topology, if A wants to communicate with C, in order to achieve this, A has to transfer the data to B, and then B will transfer the data to C. In a bus topology, all devices will communicate in this way. If you have 500 systems running on a bus, then in order to communicate between the two ends of the system, you'd have to transfer the data through all 500 stations. So it is a time-consuming process and has certain vulnerabilities. For example, if A is transferring to C and B goes down, the transfer cannot be completed. The next topology we'll review is the star topology. In the star network topology, there is a central computer or a server to which all the workstations are directly connected. Every workstation is indirectly connected to every other through the central computer. In this type of topology, all the computers are connected to a single hub through a cable. This hub is a central node in which all other nodes are connected. Here, all the devices are connected with a single server or network device that is the hub. System A, B, C, and D are connected with a single hub in case System A wants to communicate with System C or any other system connected to that hub. Communication between nodes goes through the central hub, making communication more flexible between stations. If System 1 needs to communicate to System 500, then System 1 only has to transfer to a single hub, and then that hub will redirect the information to System 500. It will not need to communicate with all the devices between. Directly, System 1 can send a request to the hub, and the hub will forward the request to System 500. Next is the ring topology. It is called ring topology because it forms a ring as each computer is connected to each adjacent computer, with the last one connected to the first. Exactly two neighbors for each device. In the ring network topology, the workstations make a closed loop configuration, with adjacent pairs of workstations being directly connected. Other pairs of workstations are indirectly connected, meaning the data passes through one or more intermediate nodes. If System A wants to communicate with System D, then System A will forward the request to System B, then to System C, and then to System D. A ring topology always chooses the shortest possible path between systems. So with System A and System D adjacent to one another at the beginning and end of the ring configuration, the data can transfer between these two systems without any intermediate nodes. Next is the mesh topology. Mesh topology is a point-to-point connection to other nodes or devices. System A is connected to System B, C, and D at the same time, so all systems are connected with each other point-to-point. The mesh network topology employs either of two schemes. The first is called a full mesh, and the second is called a partial mesh. In the full mesh topology, each workstation is connected directly to each other. And in a partial mesh topology, we can create a mesh according to our own specific requirements. For example, if there is no need for System B to be connected to System D, then we can disconnect that line. This will create a partial mesh, according to our requirements. But in this example, all the systems are in full mesh topology. The next one we'll go over is the tree topology. Here, all the systems are connected like a structure of a tree. The tree topology is made up of a root node and at least 2 other star topology configurations. This makes the tree topology a hierarchical system. It should at least have 3 levels to the hierarchy. The tree network topology uses 2 or more star networks connected together through the root node. So a tree topology uses 2 or more star networks, and as you can see in this architecture, the central computer of the star networks are connected to the main bus. Thus, a tree network is a grouping of star networks connected to a main bus or a root node. System 1 is the root node in the example above. Hybrid topologies is just a mixture of 2 or more topologies. A network in which we are using a bus and a star topology is a hybrid topology. So unlike other network fault detection and troubleshooting, it is easier in this type of topology because there are different parts to communicate. So we can easily find where the fault line is. It's easy to increase the size of networks by adding new components without disturbing existing architectures. For example, if we want to join a star network to a bus network, we are building a hybrid system. Next, we'll go over LAN protocols. So first, protocols are a set of rules or a set of guidelines, which are the guidelines for LAN. A network protocol defines rules and conventions for communication between network devices. So protocols for computer networking are all generally used for packet switching techniques to send and receive messages in the form of packets. So here is the protocol to tell the network how packets will communicate, how a system will receive a packet, and how it will send a packet. So types of LAN protocols are Ethernet, Fast Ethernet, Gig Ethernet, Wi-Fi, FDDI, and ATM lane. We will go over each of these one by one. First one is Ethernet. The Ethernet protocol is by far the most widely used one. Ethernet uses an access method called CSMA and CD, which stands for CSMA is Carrier Sense Multiple Access, and Collision Detection is CD. This is a system where each computer listens to the cable before sending anything through the network, because sometimes 2 computers attempt to transmit information at the same instant. The Ethernet protocol allows for linear bus, star, or tree topologies to exist because it frames how they will communicate. Next, we'll go over Fast Ethernet. It's a version of Ethernet, so Ethernet is the most ubiquitous local network area network protocol and utilizes copper Ethernet cables, either Cat3, Cat5, or Cat6. It also uses fiber optics or wireless Wi-Fi. It can also use fiber optics and wireless Wi-Fi connections to an Ethernet switch or Wi-Fi router. Fast Ethernet is a local area network. We are connected locally because we are using some cable connections, transmission standards that provide a data range of 100 megabits per second. Workstations with existing 10 megabit per second base Ethernet cards cannot be connected to a Fast Ethernet network. And with Fast Ethernet, we are using 100 megabits, that is 100 base T. So next is Gig Ethernet. Gig Ethernet is a transmission technology based on the Ethernet format and protocol used in local area networks. It provides a data rate of 1 billion bits per second. So Giga Ethernet is defined in the IEEE 802.3 standard and is currently being used as the backbone in many enterprise networks, as it's using 1 billion bits per second transfer rate or data rate, so many organizations, many enterprise networks are using this technology. Gigabit Ethernet is carried primarily on optical fiber because very short distances are only possible on the copper medium. Next is Wi-Fi. Wi-Fi or wireless fidelity, which is an acronym for describing the use and implementation of 802.11 Wireless Local Area Networking Protocol, WLAN. It's WLAN, not to be confused with WAN. Wireless Local Area Network. It uses 802.11 technology if you connect to your internet at home using a Wi-Fi or wireless network, or connect to a Wi-Fi network at, say, a coffee shop or airport, you are using 802.11 technology. Wireless local area networking devices use frequencies in the microwave range as a medium to encapsulate data. Here we are not connected with any cable. We are using the technology Wi-Fi wireless fidelity in which the frequencies are traveling in the microwave range. Next is FDDI. FDDI utilizes fiber optic technology as a communication medium. FDDI transmits light through glass or clear plastic strands that are thinner than human hair. These strands carry signals from place to place and are connected to laser light emitters. The laser light emitters communicate through lights that turn on and off to provide data communication. This, however, makes FDDI very expensive, and so you rarely see it in a computer LAN. Next is ATM lane. Asynchronous transfer mode. ATM is a network protocol that transmits data at a speed of 155 megabits per second and higher. ATM works by transmitting all data in small packets of a fixed size, whereas other protocol transfers have variable length packets. In other protocols, we use different size of packets to transfer or to communicate, but in an ATM lane, we use a single length size for each packet. ATM supports a variety of media such as video, CD audio, and imaging. ATM employs a star topology like the one you can see here. It is creating a star-like topology which can work with fiber optics as well as twisted pair cables. ATM is most often used to interconnect two or more local area networks. Next is WAN protocols. We have understood LAN protocols, now we are on WAN protocols. The acronym WAN stands for Wide Area Network, and it's used to refer to networks spanning much larger areas than a LAN, and often includes circuits provided by a telecommunication carrier or a privately leased line. Protocols that can transmit across longer distances, measured in miles or kilometers, are used to build WAN. When we want to communicate in different locations, then we use wide area networks, or you can say WAN. So when we need to transmit across longer distances measured in miles and kilometers, then we use WAN technology or WAN protocol. Types of WAN protocols are X.25, frame relay, ISDN, and DSL. Let's go through these. First is X.25. The X.25 protocol was adopted as a standard by the Consultative Committee for International Telegraph and Telephone, the CCITT, which is a consultative committee for international telegraph and telephones and is a commonly used network protocol. The X.25 protocols allow computers on different public networks like compulsive TimeNet or TCP/IP networks to communicate through an intermediary computer at the network layer level. X.25's protocols correspond closely to the data link and physical layer protocols defined in the Open System Interconnection, or you can say the OSI, communication model. We have two kinds of communication models. First one is OSI, the OSI communication model, Open System Interconnection model, and second one is TCP/IP communication model. So here we are talking about the OSI communication model. We have multiple layers in the OSI model and in the TCP/IP model. To be exact, we have 7 layers in the OSI model and 4 layers in the TCP/IP model. So here we are talking about an OSI model, and we are talking about the data link layer and the physical layer. So X.25 protocol corresponds closely to the data link layer and the physical layer protocol defined in the OSI communication model. Next is frame relay. The frame relay is a scalable WAN solution that is often used as an alternative to a leased line when leased lines prove to be unaffordable. Then we use frame relay. With frame relay, you can have a single serial interface on a router connecting into multiple remote sites through virtual circuits. AT&T stopped offering frame relay in 2012, but said it would support existing customers until 2016. Next one is ISDN. The Integrated Services Digital Network. ISDN was the first telecommunications service designed specifically for digital data communication. ISDN was designed to run over the standard voice digital telephone system already in place. Consequently, ISDN conforms to specifications found in telecom's digital voice network. We use in-voice communications. In telephonic communication, we use ISDN protocol. However, it took so long for ISDN to be standardized that it was never fully deployed in the telecommunication networks it was intended for. Like you can see in the picture, we have multiple telephone lines, and they are connected with ISDN topology. Next is DSL, Digital Subscriber Line. DSL is a technology for bringing high bandwidth information to homes and small businesses over ordinary copper telephone lines. XDSL refers to a different variation of DSL such as ADSL, HDSL, and RADSL. DSL technology uses normal phone line technology to send digital signals to the DSL modem. One of the major advantages of DSL over cable modem is that the line is not shared to the central office. The slow connections are rarely associated with this segment of your connection. So because DSL lines are not shared to the central office, their bandwidth is high. Next is network devices. The devices that are used in building a network that you must know are a hub, a switch, a bridge, and a router. Computer networking devices are units that mediate data in a computer network and are also called network equipment. Units which are last receiver or generating data are called hosts or data terminal equipment. We are connected in a topology by using a wire or cable or by using Wi-Fi connection, so networks using a star topology require a central point for the devices to connect. Originally, this device was called a concentrator, since it's consolidated and the hub cable runs from all the network devices. The basic form of a concentrator is the hub. The hub is a hardware device that contains multiple independent ports that match the cable types of the network. Most common hubs interconnect category 3 or 5 twisted pair cables with RJ45 ends, although coax BNC and fiber optics BNC hubs also do exist. This type of connection is called one-to-many. When we are distributing one connection to multiple systems in that particular area, we have used or we are using a hub device. A hub device distributes one channel to many connections, like you can see in the picture. The multiple devices are connected with a hub and a single device from which it is catting. It is distributing in multiple forms to multiple computers. Next is switch. So switches are a special type of hub that offer an additional layer of intelligence to a basic physical layer repeater hub. A switch must be able to read the MAC address of each frame it receives. This information allows switches to repeat incoming data frames only to the computer or computers to which a frame is addressed. This speeds up the network and reduces congestion. Switches operate at both the physical link layer and the data link layer of the OSI model. The basic working of a switch is one-to-one connection. Here we are giving one input and getting one output. As you see in the hub, we are giving one input and getting multiple outputs. One-to-many connection, but a switch is one-to-one connection. A hub is broadcasting the message. For example, when we are connected to a hub and System A wants to connect with System C, then System A will broadcast the packet over all the systems that are connected to the hub. With a switch system, if A wants to communicate with System C, then only C will get that packet. The switch will not broadcast the packet. This is the main difference between hubs and switches. Next is a router, or router device. Routers are network devices used to extend or segment networks by forwarding packets from one logical network to another. Routers are most often used in large internet networks that the TCP/IP protocol suites and for connecting TCP/IP hosts and local area networks or LANs to the internet using dedicated leased lines. Routers work at the network layer of the OSI model for networking to move packets between networks using their logical addresses. Next is NICs, Network Interface Card Device. NIC is a hardware card installed in a computer so it can communicate on a network. The network adapter provides one or more ports for the network cable to connect to, and it transmits and receives data through the network cable. Every network computer must also have a network adapter driver, which controls a network adapter. Each network adapter driver is configured to run a certain type of network adapter. We have a network adapter in our networking devices which help to communicate, you can say. For that, we have multiple ports in our network device on our network interface device NIC. We have 65,535 ports to be exact, networking ports in our NIC. We will go over ports more in the later class. For now, this concludes the first class of Course 1. Thank you very much, and we'll see you in the next class. Hey everyone, Welcome to Class 2 of Course 1, Networking Fundamentals. Now in Class 2, we will learn about the concepts of IP, answering questions like what is IP, IP protocol, IP addresses, and other IP concepts. First of all, for IP, we just need to understand that if a device wants to communicate on the internet, it requires an IP address. When the device has an IP address and the appropriate software and hardware, it can send and receive IP packets. Any device that can send and receive IP packets is called an IP host. IP addresses consist of a 32-bit number, usually written in dotted decimal notation. When we are in a network, then we have a unique identification, and that particular unique identification is the IP address. So IP addresses are a unique identification number, which we are using anytime we use the internet. Whenever we are connected with the internet, we get an IP address, whether you're connected in your mobile or any other system. So IP addresses consist of, again, a 32-bit number when we are using IPv4 addresses, and when we are using IPv6 addresses, meaning version 6, then we are using a 128-bit number, which we'll get into more here in just a bit. So first, let's talk about packets. A packet is the basic unit of information in network transmission. We communicate in a packet form whenever data is transmitting over the internet. So most networks use TCP/IP as the network protocol, or a set of rules for communication between devices. They fit into the standard model of networking protocols known as the OSI model. The structure of packets and packet switching network allows for fast and reliable data transmission and makes networks like the internet possible. Whenever we are connected with internet, we have a unique IP address and the data is transmitting in a packet form, and that particular packet is transmitting between unique IP addresses. Next, let's cover more about IP addresses. So an IP address is an address used in order to uniquely identify a specific device on an IP network. The address is made up of a 32 binary bit number, which can be divisible into a network portion and the host portion with the help of a subnet mask. The 32 binary bits are broken into 4 octets. 1 octet is equal to 8 bits. Each octet is converted into a decimal and separated by a period or a dot. Like in this case, you are using an IP address 192.168.1.5, then you are using a 32-bit number. It's a 32-bit IP address. To check your IP address, just go to the command prompt, type there ipconfig, and you will get your IP address. In case you are using a Linux OS machine, then just type in your command terminal ifconfig, and you will get your IP address. So just check out whether you're using a 32-bit number or you are using a 128-bit number so you can know what your network is using. Remember, 32-bit numbers are IPv4. Remember, 32-bit number addresses are IPv4 and 128-bit address numbers are IPv6. So next is IP service port. So the service port interface controls communicate through and is statistically mapped by the system to the service port. The service port can obtain IPv4 addresses using DHCP, or it can be assigned a static IPv4 address. But a default gateway cannot be assigned to the service port interface. The default gateway cannot be assigned to the service port interface. IP service port, as I have told you, we are using multiple ports in our system, and this is the port for IP service. Next is IP Internet Protocol. So the Internet Protocol is a method or protocol by which data is sent from one computer to another on the internet as we are on the internet. Whenever we're on the internet, we have an IP address. Without an IP address, we cannot communicate. So whenever we are connected with internet, we are communicating through IP addresses. So IP addresses or Internet Protocol is a protocol or method through which data is sent from one computer to another computer. Each computer known as a host on the internet has at least one IP address that uniquely identifies it from all other computers on the internet. That's the only reason you are not getting another system's data. In the case that there was no unique identification, then there may be cases where your data would be transmitting to another device and your device would be receiving data from another machine. It's the unique identification that makes it possible to send information to specific machines. IP by itself is something like the postal system. Most networks combine IP with a higher level protocol called TCP, which we will discuss later. So next is IPv4 addresses. These are Internet Protocol hierarchies that contain several classes of IP addresses to be used efficiently in various situations as per the requirements of hosts per network. The IPv4 addressing system is divided into 5 classes of IP addresses. We have 5 classes of IP addresses. All the 5 classes are identified by the first octet of the IP address. First, we'll start with the Class A address. The first bit of the first octet is always set to 0. Thus, the first octet ranges from 1-127. For example, Class A addresses only include IP starting from 1.x.x.x to 126.x.x.x only. The IP range 127.x.x.x is reserved for loopback IP addresses. We have 1 to 127, but we can only use 1 to 126 IP addresses. And 127 is reserved for a loopback IP address, right? In Class B addresses, the IP address has the first 2 bits in the first octet set to 10. That means Class B IP addresses range from 128.0.x.x to 191.255.x.x. It's the first octet set to 10. The default subnet mask for Class B is 255.255.x.x. You can calculate that Class B has 2 to the 14th power network addresses, and 65,534 or 2 to the 16th power minus 2 host addresses. In Class C, the first octet of the Class C IP addresses has its first 3 bits set to 110. In Class A, the first bit of the first octet is set to 0. In Class B, the first 2 bits of the first octet is set to 10. And in Class 3, or C, the first 3 bits of the first octet is set to 110. Here you can see 110. So in Class C, IP addresses range from 192.0.0.x to 223.255.255.x. The default subnet mask for the Class C is 255.255.255.x. Class C gives 2 to the 21st power network addresses. 254, that means 2 to the 8th power minus 2 host addresses. In Class D, the very first 4 bits, here I am talking about the 4 bits of the first octet of your Class D IP addresses, are set to 1110. Here it is 110. Here it is 1110. In Class D, the IP addresses range from 224.0.0.0 to 239.255.255.255. Class D is reserved for multicasting. We use this when we require multicasting host addresses from the IP address in Class D, which does not have a subnet mask. In Class E, the last class, the IP class is reserved for experimental purposes only, for R&D and study. IP addresses in the class range from 240.0.0.0 to 2555.255.255.254. Like Class D, this class is not equipped with any subnet mask, so we have discussed Class A, B, C, D, and E. Next is TCP Transmission Control Protocol. As we have discussed IP Internet Protocol, now we are discussing TCP Transmission Control Protocol. So Transmission Control Protocol, or TCP, is a network communication protocol designed to send data packets over the Internet. TCP/IP is a set of rules and protocols governing communication among all computers on the Internet. TCP/IP is a combination of 2 separate protocols, TCP and IP, Transmission Control Protocol, and Internet Protocol. When we are using a TCP/IP communication channel, as I have told you, we have 2 kinds of communication channels. The first one is OSI, and the second one is TCP/IP. When we are using TCP/IP communication channel, then we are using Transmission Control Protocol and Internet Protocol. 3 most common TCP/IP protocols are HTTP, HTTPS, and FTP. These are TCP/IP protocols. We will see HTTP first. So HTTP, or Hypertext Transfer Protocol, is used between a web client and a web server. Whenever you are using your browser, you can see HTTP in your URL. In your address bar, you can see HTTP, and it is using this for communication between client and server for a non-secure data transmission. As I said, it is a non-secure data transmission. For secure communication, we use HTTPS. So a web client or internet browser on a computer sends a request to a web server to view a web page. Then we are using HTTP. The web server receives the request and sends the web page information back to the web client. Without HTTP, we can't use the internet, so it's the HTTP protocol. Next one is HTTPS, which I went over very vaguely. So HTTPS is used between a web client and a web server as HTTP, but the difference is HTTP is non-secure and HTTPS is a secure communication. Often used for sending credit and transaction data for other private data from a web client, i.e. internet browser or on a computer. You're sending this to a web server, and you can share your credentials, you can share your credit card numbers and things like that in HTTPS because it's a secure channel between your browser and the server. It uses a SSL technology and encryption, which we'll discuss later. So HTTPS provides authentication of the website and associated web server with which one is communicating. Next is FTP, File Transfer Protocol. So FTP uses the internet TCP/IP protocol to enable data transfer. This is used between two or more computers. One computer sends data to or receives data from another computer directly. FTP uses a client-server architecture, often secured with SSL TLS. When we are using FTPS, then we are using secure communication. When you are transferring a file, you are using FTP protocol. Next is User Datagram Protocol, or UDP. User Datagram Protocol is a transport layer protocol defined for use with the IP network layer protocol. It is defined by RFC 768, written by John Postel. UDP provides a minimal, unreliable, best effort message passing transport to application and upper layer protocol. UDP and its UDP Lite variant are unique in that they do not establish end-to-end connection between communicating end systems. We will discuss later about the difference between TCP and UDP. So next is ICMP, Internet Control Message Protocol. ICMP is used by error reporting protocol network devices like routers that are used to generate error messages to the source IP address when network problems prevent delivery of IP packets. It is an extension to the Internet Protocol defined by RF7 792. ICMP messages generated by a router R1 in response to message sent by H0 to H1, H0 to H1, and forwarded by R0. Next is DNS, Domain Name System. It is an internet service that translates domain name into IP addresses. Again, we are using IP addresses whenever we are connected with the internet, and this is a system which converts domain name systems to IP addresses and vice versa. Because domain names are alphabetic, they are easy to remember. The DNS system is in fact its own network. If one DNS server does not know how to translate a particular domain name, it asks another one, and so on, until the correct IP address is returned. So domain name systems are used for converting domain names to IP addresses and IP addresses to domain names. So at this point, we have finished Class 2 of Course 1. Thank you, and we will see you in the next class.
Hello everyone. So now we're going to start Class 3 of Course 1. And this is on TCP dump, IP behavior. So in this class we're going to discuss TCP dump and IP behavior. Let's start with TCP dump. So TCP dump is an open source command line tool for monitoring, that is sniffing, network traffic. And it's a command line tool that we would be using in Linux or Unix OS. and it will give the traffic of the network. So it will give us the packet details. TCP dump works by capturing and displaying packet headers and matching them against a set of criteria. It understands Boolean search operators and can use host names, IP addresses, network names, and protocols as arguments. TCP dump command will work on most flavors of the Unix operating system. And as a command line tool, it will capture and display packet headers, the kinds of requests we are forwarding in a network. Basically, the whole network will be captured by TCP dump on Unix or Linux. Recognizing and understanding. Every location or device on a network must be addressable by using an IP address. Now, this is simply a term that means that it can be reached by referencing its designation under a predefined system of addresses. And that would be the IP address. Each IP address must be unique on its own network, because if you want to communicate between different computers and they have the same IP address, this will become impossible. It will have no way of knowing where to forward the request. So each IP address on a network must be unique. And then an IP address allows network resources to be reached through a network interface. This is all about communication and connecting between the computers and the devices on the network. So next, we're looking at the difference between IPv4 and IPv6. So as we've discussed in earlier classes, we have two kinds of IP protocols. These are two versions of IP protocols, and that is v4 and v6. And they're basically revisions that are widely implemented on systems today. IPv4 is the fourth version of the protocol, and it is currently what the majority of systems supports. However, the world now has too many internet-connected devices for the amount of addresses available through IPv4. A typical IPv4 address looks something below like 192.168.0.5. That's an IPv4 address. Then IPv6 is the sixth version of the IP protocol, and it will look like something below, as you can see here. And so you notice the difference. IPv4 address is a 32-bit value, and IPv6 is the size of 128 bits. So this is why it's important that we start thinking about IPv6, because there are many systems, there are millions of systems that are connected in a network at a single time. And so IPv4 has a limit. It has a 32-bit value. That's why as systems and networks are increasing day by day, we need to create IPv6. So if you want to check if you have IPv4, which is 32-bit, and IPv6, which is 128-bit, you can open your command prompt and type ipconfig in case you're using Windows OS. And then you'll get your IP address. In case you're using Linux or Unix OS, then go to your terminal and type ipconfig and you will get your IP address. And just check it out, which version of IP you guys are using, because it's IPv4 or it's IPv6. In case you're using Linux or Unix OS, then go to your terminal and type ifconfig. Then you will get your IP address. Just check it out. You need to know which version of IP you guys are using, because it's either IPv4 or IPv6. Next is IPv4 address, classes and reserved ranges. So the IP addresses are typically made of two separate components. The first part of the address is used to identify the network that the address is a part of. And that part that comes after this is used to specify a specific host within that network. So to explain, here we are using 192.168.0.5. Now someone either has the IP 192.168.0.6 and 192.168.0.7. So these types of IP addresses will vary within the same network, because the first part of the address is used to identify the network. And so that is the part which is 192.168. Then the part that comes afterward is used to specify the specific host within that network. And it's a specific number, like from previously it would be 0.5, 0.5, 0.6, 0.7, and then 0.8, and so on. So where the network specification ends, the host specification begins. This all depends on how the network is configured. So now we're going to look at UDP behavior. So we have two kinds of protocols, as we've discussed, TCP and UDP. And so here we are going to discuss the behavior of UDP. Now the behavior is not specific for UDP, but it is for IP. And unless you have a multicast target, the PC tries to find out the MAC address, the network card, for the IP by doing an ARP, Address Resolution Protocol request, which is in the form of a broadcast. Is anybody there having this IP? So the way UDP works, it works on an ARP protocol. An ARP is Address Resolution Protocol, which converts MAC to IP. And then RARP, that's Reverse Address Resolution Protocol, converts IP to MAC. So UDP works on ARP, and it forwards or broadcasts the packet to simply ask if anybody has a certain IP address. Now the computer which responds, I am at MAC and I have the IP you ask for, gets put into the ARP table whenever the system tries to send something to the IP. So it will send a packet asking if anybody has a certain IP address on that particular system, and then if anyone on that particular system responds that I am at the certain MAC address, it'll give its MAC address, then it'll give the IP. So that gets put in the ARP table, and whenever the system tries to send something to the IP, the next time UDP will work by directly forwarding to a particular system, which is maintained in its ARP table. Next is UDP and TCP. So UDP is a connectionless service, and no session is established between hosts. It does not guarantee or acknowledge delivery or sequence data. However, TCP is a connection-oriented service. A session is established between hosts, and TCP guarantees delivery through the use of acknowledgements and sequence delivery of data. So there's a very simple thing that separates the two. TCP works on a three-way handshake, whereas UDP does not. So the idea of a three-way handshake simply means acknowledgement. So it's just that TCP works through acknowledgement, while UDP does not. UDP is only a broadcast, and it will not work on a three-way handshake. TCP is a connection-oriented service, and UDP is a connectionless service, because UDP has no acknowledgement, while TCP does. Now we're going to look at ICMP behavior. So we've already discussed ICMP briefly, but here we are on ICMP behavior. Host A is sending a packet to host B, and host A's default IP router is router R1. Because host B is a remote host, host A forwards the packet destined for host B to its default router R1. So R1 checks its routing table and finds that the next hop for the route to the network for host B is router R2. If host A and R2 are on the same network that is also directly attached to R1, an ICMP redirect message is sent to host A, informing it that R2 is the better route when sending to host B. The ICMP unreachable message is received in the server to client direction, so it's like you are using a ping command. So what you would do is open your command prompt, open your terminal, and type their ping. And so when you ping their IP address, you will receive some packets. And this request uses the ICMP protocol, the Internet Control Message Protocol. So the ping command will forward a request of ICMP echo. In case somebody is connected on the IP you have requested and is connected to your router, it will show the packets. Otherwise, it will show the unreachable message. ICMP doesn't actually have ports, so you can't actually ping a port. More accurately though, pinging a port is a misnomer. When someone speaks of pinging a port, they are actually referring to using a layer 4 protocol, such as TCP or UDP, to see if a port is open. When someone pings port 80 on a box, that would usually mean that they're sending a TCP SYN to that system in order to see if it's responding. So just remember that the real ping, uses ICMP, which doesn't use ports at all. So now we have finished class 3. Thank you. Hello everyone, so I'm going to start class 4, and this is all about the router and the routing protocols. So we'll start with the router. Routers use headers and forwarding tables to determine the best path for forwarding packets, and they use protocols such as ICMP. So as I've already discussed, a router is used just to forward a packet. It routes a packet. And a router is connected to at least two networks and decides which way to send each information packet. A router is located at any gateway where one network meets another. This is similar to where the internet meets the internet, and it includes each point of presence on the internet. A layer 3 switch is a switch that can perform routing functions. So next we're going to look at the broadband router. So what is a broadband router? Broadband routers can do different types of things. They can be used to connect to the computers or to connect to the internet. If you connect to the internet through the phone and are using voice over IP technology, then you need a broadband router. So if you're connected through the internet and you're using telecommunications, then you would need a broadband router. So now we're going to look at a wireless router. So this is the type of router that we see most often nowadays. A wireless network creates a wireless signal in your home or office. So whenever you are getting a wireless signal, that means that they have used a wireless router. Any PC within range of a wireless router can connect and use the internet. So in order to secure your wireless routers, you simply need to secure it with a password or get your IP address. And when you log into your router with your user ID password that comes with your router, then you can access these settings. For all the settings, you have a router panel. This can be accessed through your network. It will run in your browser by using the default gateway and the default IP address. Then you can change the settings for your wireless router. Then there's the core router. So this is a router that resides within the middle or backbone of the LAN network rather than at its periphery. In some instances, a core router provides a step-down backbone, interconnecting the distribution routers from multiple buildings of a campus. So when you are using multiple buildings and you need to connect them, this is the type of router that you would use. So next is routing. What exactly is routing? Because we've already discussed routers and the different types of routers that we can use. Now we should probably look at what exactly routing is. In internetworking, it's the process of moving a packet of data from source to destination. And this is just a simple definition: moving a packet of data from one source to a destination. Routing is usually performed by a dedicated device called a router, which we've already discussed, and each intermediary computer performs routing by passing along the message to the next computer. Now, routing is often confused with bridging, which performs a similar function, but really, routing is nothing like bridging. Bridging is the concept when you are going to use multiple networks. So in case I want to connect one network with another network, say I have complete network A and a complete network B, then I will connect them with a bridge, whereas routing is within a network. Static routing. So next is static routing. What exactly is it? So here the router learns about remote networks from neighbor routers or from an administrator. The router then builds a routing table. So every router has its own routing table in which they know how to route a packet from source to destination. So it has a complete routing table. If the network is directly connected, then the router already knows how to get through the network. So in case I'm talking about your internet, it has all knowledge of all the IP addresses, so it knows all the network connections. And so the routers then update each other about all the networks they know. Dynamic routing. So dynamic routing performs the same function as static routing, except it is a bit more robust. So dynamic routing allows routing tables and routers to change as the possible routes change. It works dynamically and it changes their path. So there are several protocols used to support dynamic routing, and these include RIP and OSPF. We will discuss these later. Dynamic routing is when we are accessing or the router is updating the routing table again and again, and that is dynamic routing. Routing protocol. The purpose of routing protocols is to learn of the available routes that exist on the enterprise's network. Some of the most common routing protocols include IGRP, EIGRP, OSPF, IS_IS, and BGP. These are the routing protocols. There are two primary protocol types, although many different routing protocols are defined within those two types. When a route becomes unavailable, all router tables must be updated with that new information. So when you're trying to get the route, just update the routing table of that router and you'll be able to get connected. Next is Interior Gateway Routing Protocol, IGRP. So we already know of IGRP, EIGRP, OSPF, ISIS, and BGP. So we're going to look at IGRP first, Interior Gateway Routing Protocol. So IGRP is a distance vector routing protocol developed by Cisco Systems for routing multiple protocols across small and medium-sized Cisco networks. This contrasts with IP-RIP and IPX-RIP, which are designed for multi-vendor networks. IGRP does recognize assignments of different autonomous systems and automatically summarizes at network class boundaries. There's also an option to load balanced traffic across equal or unequal metric cost paths. So IGRP is used in the Cisco networks. So next is EIGRP, the Enhanced Interior Gateway Routing Protocol. So EIGRP is a hybrid routing protocol developed by Cisco Systems. It has characteristics of both distance vector routing protocols and link state routing protocols. It is proprietary, which requires that you use Cisco routers. And so this is only able to be used on Cisco routers. EIGRP will route the same protocols that IGRP routes, that's IP, IPX, DECnet, and AppleTalk. Finally, we have access control protocols. There are many reasons to configure an access list. So for example, you can use access lists to restrict the contents of routing updates or to provide traffic flow control. And one of the most important reasons to configure access lists is to provide security for your network. You should use access lists to provide a basic level of security for accessing your network because it essentially determines who has permission to access the network and who doesn't. It's a complete list of all the IP addresses which have access and which do not have access. And so when you have multiple IPs trying to get access, it can determine which ones are to be blocked. So it can block external IPs, and it can block anything that is not on the list or is on the list to be blocked because it is a complete list of those that have permission to access and those that don't. And so that's it for this class. Thank you.
Hello everyone, we are now in Class 5 of Course 1. Here in this class, we will learn about physical security. Physical security measures, physical security threats, physical security controls, and threat systems. It's the last class of Course 1. So first thing, physical security. Why are we talking about physical security here? Because it's security for your devices, right? We should be protecting our devices from theft, damage, and many other factors. So physical security is the first layer of protection for any computer device and its data. Imagine you set up a router, and that particular router can be accessed by anyone. You have set it outside your building, so anyone can steal, anyone can access, anyone can connect, and that device can connect with that device and get access to your network and see whatever you are doing. So physical security is a first layer of security, and we should understand how it works to avoid these situations. So it involves the protection of assets such as hardware, networks, and data from attacks that cause loss or damage. There are various factors that affect the physical security, such as damage, theft, dust, fire, water, floods, earthquakes, etc. We have to prevent our devices from being affected by these circumstances so that it can be secure, so that our data can be secure. The objective of physical security is to prevent any unauthorized access to the computer system, as I have told you, to prevent tampering or stealing of data from the computer systems. For example, if your mobile device is not locked with a password, it can be accessible by anyone. Then anyone can steal your data. Protect the integrity of the data stored in the computer, in case somebody will modify that particular file or piece of data. So we have to protect them also. Prevent the loss of data and damage to system against any natural calamities. So physical security threats are environmental threats and man-made threats as well. It's an environmental threat that happens naturally, but what about a man-made threat? So let's look into these threats one by one. Environmental threats are floods, fire, earthquakes, dust, and man-made are things such as terrorism, wars, explosions, dumpster diving, theft, vandalism. We have to prevent our devices from these threats. Here are some physical security controls. First one is on-premises and company surroundings. What type of security are you using to protect your devices from physical thefts or physical threats? So first one is premises and company surroundings. Have you used fences, gates, walls, guards, alarms, CCTV cameras, intruder systems, panic buttons, burglar alarms, windows and door bars, deadlocks, etc., or not? So you should take care of these aspects. Also, we have to take care of the environment to protect devices from physical theft and physical threats also. Second one is the reception area. Your reception area is your front area, your front door, and if it's not secure, neither is your building. So lock the important files and documents. Lock equipment when not in use. Lock the server and workstation areas. Lock the system when not in use. Disable or avoid having removable media and DVD-ROM drives, CCTV cameras, workstation layout design, etc. Have you secured your server? Have you secured your workstation area from physical threats? Next is access control. What are the accessing permissions? What are the controls on accessing permission? Have you set that or not? Do you have the separate work areas? Have you implemented biometric access controls, entry cards, man traps, etc.? Wire trappings? Inspect all the wires carrying data routinely. Protect the wire shield cables. Never leave any wire exposed because your data is transmitting through those wires, right? Environmental control. Is your space secure from humidity and air conditioning, HVAC, EMI shielding, etc.? So we'll see next physical security measures. Have you used locks for your system at your doors on your mobile device or not? Locks act as a primary method of controlling the physical access of the information systems, and removable storage devices. Locks provide different levels of security depending on their design and implementation. Just imagine you are going and you are carrying your laptop and it is not secured physically, right? Someone can steal your laptop and your data can be accessible then. What will you do? You have to be preventative to keep people out, build any kind of lock, and take control of your access control. Next is physical security measured by biometric systems. So biometric systems refer to the identification or identity verification of the individual by using their characteristics like fingerprinting, retinal scanning, iris scanning, voice recognition, face recognition, vein structure recognition. These unique characteristics we use in biometric systems for verification. Next is fire prevention. Have you prevented your devices, your equipment, your infrastructure from fire? Fire accidents may occur because of a short circuit, which may cause heavy loss and destruction. So all the emergency doors and corridors are kept clear. Use good quality wiring, tools, and equipment. Ensure that trash is emptied regularly. There should be no waste. Make sure the user knows who to call during an emergency. And you should know how to use a fire extinguisher in case there is an accidental fire. Next, HVAC considerations. HVAC is all about heating, ventilating, and air conditioning. It prevents your systems from heating via poor ventilation. So finally, we are on the modulus summary. At last, we are going to summarize the whole course. First one is computer network, a collection of so many computers that communicate with each other. There are several types of computer networks like LANs, WANs, MEN, etc. So network technologies are used to arrange computers for transferring and receiving data through its network technology. A computer system has different types of protocols in LANs and WANs, as we have discussed. So computer network devices work like mediators to transfer and receive information. These are mediators who are just forwarding the data between the sender and the receiver. The devices are just forwarding the request. Next is if a device wants to communicate using TCP/IP, it needs an IP address. In case you want to connect to the internet, you need an IP address. An IP address consists of a 32-bit number, usually written in dotted decimal notation. IPv4 addresses has a 32-bit number IP address, as just discussed, and IPv6 addresses have a 128-bit number IP address. A network protocol defines rules and conventions for communication. Between your network devices, we are using networking protocols. Gigabit Ethernet is carried primarily on optical fiber. HTTPS is used between a web client and a web server for secure data transmission. One thing I want to tell you, in case you are connected with the internet and you are using HTTP protocol, you should not transfer your credentials, just something to keep in mind. In case you are not using HTTPS protocol, then you will not be forwarding your credentials, your social security number, your contact number, or anything which is personal to you, anything which is important to you. Don't forget, in case it is HTTP website, you will transfer all the credentials on the important documents when you are connected only with an HTTPS protocol, because it's a secure one. Next is TCP dump command, which will work on most flavors on Unix OS by using TCP dump command. We get TCP headers, we get packet headers. Every location or device on a network must be addressable. A typical IPv4 address looks something like this, as I have told you. It's a 32-bit number. Where the network specification ends and the host specification begins depends on how the network is configured. Just remember that the original real PING uses ICMP protocol, which does not use ports at all. So here we have finished Course 1, Networking Fundamentals, of your Security Essential training. Thank you, and we will see you in future courses.
Welcome to Course 2 of Security Essentials, Defense in Depth. Our objective of this course is Information Assurance Foundation, Risk Models, what is authentication versus authorization, data classification and vulnerabilities. Class 2 will cover security policies, elements when well written, how policies serve as insurance, and roles and responsibilities. In Class 3, legal and regulatory requirements, disaster recovery and planning. In Class 4, we'll cover password management. We will have password cracking for Windows, alternate forms of authentication such as tokens and biometrics, as well as single sign-on and radius. And finally, in Class 5, we will cover incident handling. We'll have preparation, identification and containment, eradication, recovery, and lessons learned, investigation techniques, and computer crime, and we'll finally cover ethics. So now we will begin Class 1, Information Assurance Foundations. What is defense in depth? Defense in depth is the coordinated use of multiple security countermeasures. It is used to protect the integrity of the information assets in an enterprise. The strategy is based on the military principle that it is more difficult for an enemy to defeat a complex, multi-layered defense than to penetrate a single defense. We use multiple security softwares to defend our information, such as firewall, antivirus, anti-malware, etc. These kinds of software will create a complex system for an attacker. So if you have a firewall in your system, you have an antivirus, all of that, all of these security softwares will create a complex structure for the attacker. This is what's known as defense in depth. Next is layered security. What is layered security? Layered security is also known as a layered defense. There is a difference between defense in depth and layered security, which I'll cover in a moment. Layered defense describes the practice of combining multiple mitigation security controls to protect resources and data. A layered approach to security can be implemented at any level of a complete information security strategy. It is always a set of security measures to provide layered and comprehensive defense against these risks. For example, if I am using a network, I will have created multiple layered security. On the network layer, I've created an intrusion detection system, then I'll have a firewall. And so these are on the network layer. Then on the application layer, I'll have an antivirus, I'll have anti-malware, so every layer is secured. So any potential attacker will have to crack all of these layers if he wants to get to information, which will make it a lot difficult if it's layered rather than a single defense. So next is layered security versus defense in depth. Layered security and defense in depth are two different concepts with a lot of overlap. Defense in depth is security we have used for multiple applications to protect our information, and layered security we have created security software or hardware on each and every layer. They are not competing concepts. A good layered security is extremely important to protecting your information technology resources. If you're going to protect your information, you must know layered security and defense in depth. Think for a moment how you protect your own information. Are you using layered security, multiple security? Do you have a comprehensive defense in depth? Now we have a risk model. This shows the risks that you or your organization can have, how vulnerable, and how you will calculate the risks you have. So there are many types of computer security threats in the world. Some are extremely harmful, while others are harmless, though annoying. There are ones that don't do any physical damage to your computer, but they have the capacity to empty the numbers in your bank account. There are also a number of untargeted security risks that come from external sources. This makes up a complete risk model. As you can see here, there is financial risk, there's business risk, and then there's operational risk. In financial risk, you have liquidity or credit concentration and counterparty. Business risk, you have strategic or reputational risk. If you have operational risk, you have legal complaints, disaster theft, and fraud, system management, process management, and human resources. So you have to calculate the risk model first in case we are going to create a security for our organization. So first you have to know what the risk factor is, and then from where we can get attacked. You need to know where the vulnerable parts are in your system in order to create an information security infrastructure. So next is authentication. Authentication is the process of determining whether someone or something is in fact who or what they declare to be. It's the process of identifying an individual, usually based on a username and password. In your system, this is the authentication method. So authentication is just a method to get identification. So any authorized or unauthorized person can be authentic. It's a very important distinction, and I'll get to that in a moment. But in security systems, authentication is different from authorization. So any authentic person can be authorized. Next, we have authorization. Authorization is the process of giving someone or something permission to do or have something. Like I said, every authorized or unauthorized person can be authentic. If any unauthorized person has your credentials, such as a username or password, and those are the only methods for which we can verify authentication, then an unauthorized person can use your credentials to log in. So that unauthorized person is now an authentic one, but he still has no permission to get access in that system, so he is unauthorized. Basically, authentication is to identify, and authorization is what you have access to. You can think of these concepts as simple questions. In authentication, you ask, who are you? Authorization, you ask, what can you do? Who are you and what can you do? It's a very important concept. Authorization is usually coupled with authentication so that the server has some concept of who the client is that's requesting access. The type of authentication required for authorization may vary. Passwords may be required in some cases but not in others. If you use a multiple authentication system like biometric scanners, passwords, etc., in some cases there is no authorization. Any user can be able to use a resource or a file simply by asking for it. So again, in authentication, we have who are you, and in authorization, we ask what can you do. Next, we have encryption. Encryption involves the process of transforming data so that it's unreadable by anyone who does not have the decryption key. With encryption, you convert data into an unreadable format, and whomever has the decryption key can convert it back into a readable format. All data and SSH sessions are encrypted between the client and the server when communicating at the shell. By encrypting the data exchanged between the client and server, information like social security numbers are unreadable by anyone without the key. Now we'll cover the difference between authorization and authentication again. Once again, authentication is the process of verifying who you are. When you log into a computer with your username or password, you are authenticating. And authorization is the process of verifying that you have access to something or what you can do, such as gaining access to a resource or a directory on a hard disk, because the permission configured on it allows you access. That is considered authorization. So again, authentication, who are you? Authorization, what can you do? It's very important. Now we're going to talk about data classification. Data classification is the process of organizing data into categories for its most effective and efficient use. A well-planned data classification system makes essential data easy to find and retrieve. This can be of particular importance for risk management, legal discovery, and compliance. Once a data classification scheme is created, security standards will specify what to do with that data. So you have to classify your data so that you can retrieve it without delay and it's properly categorized. For example, you don't want social security numbers floating around in the open. Here we have the specific data categories. For ease of use, different types of data have been broken into 6 general categories. So what are these categories? First, there's general identification data. There's health and medical, financial, academic, employment, and information technology data. You have to categorize your data so that you want to retrieve it anytime you need it. Next, we have vulnerabilities. A vulnerability is a weakness. Everybody and everything has vulnerabilities. Humans are vulnerable to certain attacks. Systems are vulnerable to other kinds. But for the sake of this class, we're going to talk about vulnerabilities in cybersecurity parlance. So a vulnerability refers to a flaw in a system that can leave it open to attack. A vulnerability may also refer to any type of weakness in a computer system itself, in a set of procedures, or in anything that leaves information security exposed to a threat. Vulnerabilities are what information security and information assurance professionals seek to reduce. So we want to reduce the vulnerabilities of our information systems, have to decrease the vulnerabilities. So a security professional's work is only to reduce vulnerabilities. And finally, here are some types of security vulnerabilities. These are just a few examples of the ways that attackers can penetrate your system. We have buffer overflows, invalidated input, race conditions, access control problems, weaknesses in authentication, authorization, or cryptographic practices. So these are just a few examples, but there are many other types of security vulnerabilities. And as a security professional, it's your job to reduce these vulnerabilities as much as you can so that attackers cannot break into your system, or at the very least, make it extremely difficult to break into your system. So that concludes Class 1 of Course 2. We will see you in the next class. We will talk about computer security policies. Welcome to Class 2 of Course 2. In this class, we will cover computer security policies. A security policy is a document that outlines the rules, laws, and practices for computer network access. Organizations rely on IT resources today to handle the vast amount of information. Everything we do these days is on the internet, so the need for information security to secure our data is vital. Because the data can vary widely in type and in degree of sensitivity, employees need to be able to exercise flexibility in handling and protecting it. Without some degree of standardization, however, inconsistencies can develop that will introduce risk. So in the next couple slides, we'll cover a few security policies. The first one being user policy. A user policy defines what users can and must do to use your network and an organization's computer equipment. It defines what limitations are put on the user to keep the network secure, such as whether they can install programs on their workstations, types of programs, and others. A user policy details what a user can do and what he can't do. Like password policies, this policy is to help keep users' accounts secure. Acceptable use of hardware such as modems. No modems connected to the internet are allowed without a personal firewall. So that would be an example of a user policy. So next we have IT policies. These policies include general policies for the IT department, which are intended to keep the network secure and stable. There's the backup policy, which defines what to back up, who backs it up, where it is stored, and for how long, how to test the backups, and what program is used. Those are some examples of backup policy. We also have client update policies. Update clients on how often and using what means or tools. We have the firewall policy. What ports to block or allow, how to interface, and how to manage it. Who has access to the control console. Next, we have some general policies like high-level program policies. It defines who owns other policies, who is responsible for them, the scope and purpose of policies, any policy exceptions, related documents or policies. For example, if you have a business continuity plan, it will include the following plans: server recovery, data recovery, end user recovery, emergency response plan, workplace recovery. These are all in general policies for a business continuity plan. So in the event of a disaster or a breach, these policies will minimize the interruption of the business. So next we have the security policy document. A security policy document has several functions. As the term implies, it documents security policies, although it does more than just document them. It provides a framework within which policy can be written, modified, and assessed. What to do, what not to do, when to do it, how to do it, all of that is in the security policy document. Now we will cover what a security policy document should have. We'll begin with the introductory elements. The introductory section of a security policy sets the policies in the context of the business that they are intended to protect. The introduction should be tailored to the business, but it should address at least these areas. It should address the purpose, the scope of the document, and the policies specific to the organizational responsibilities. Next, we're on purpose. Why are we creating these policies? The purpose of a security policy document, while somewhat standard, can be influenced by the extent to which the business deals with confidential information. The means by which systems and networks are administered, either dedicated in-house staff, additional duties for other staff, or outsourced. Security policies are an excellent way to complement the hardware and software security measures of your organization. By using a particular piece of software, security policies allow you to identify who is the responsible for what he has to do, when he has to do it, and what he cannot do. Next, we have scope. The scope definition should clearly delineate what is covered in the policies and should resolve ambiguity about what is not covered. In particular, small businesses must decide whether the security policies cover acceptable use policies and disaster recovery policies. Many sources recommend they do, but for small businesses it may not be necessary. So next we are on threat and risk assessment. The threat and risk assessment is one of the most important elements of the security policy document. The threat assessment identifies what the policies are intended to protect against. Some threats are standard, for example, the threat of attack from the internet and the HoneyNet research project shows. The risk assessment is very specific to the business and its unique situation. What are the risk factors that an organization has? From which threats are we going to secure our data? What kind of data are we going to secure? All of that must be written in the risk assessment. Next, we have computer security incident procedure steps. So as you can see, there are 6 procedures: preparation, identification, containment, eradication, recovery, and last, lessons learned. If there is any kind of incident in the organization, whether it be a cyber attack or a natural disaster, these steps outline what they have to do and how they have to do it. First is to prepare. This is the steady state that any organization should be at. When an incident occurs, the first thing that happens is you identify what happened, then containment, eradication, recovery, and lessons learned. And occasionally, in some cases, you may need to go back and redo a step. We will now discuss each step in more detail. First is to prepare. Create your policies, checklists, procedures. Next is to identify. Have methods in place to detect an incident and provide a trail of evidence. Then containment. Assess the situation in such a way the intruder does not know that you are aware of their presence until you are ready to implement your response. Eradication removes malicious code and possibly reinstalling the system to be sure to remove all backdoors or malicious code and possibly restore from backups. Recovery means back in production, eventually restoring backups or re-imaging a system. It's where you return to a normal operational status. And the last step is lessons learned. This is the important part. This step is where you document what you have learned from this particular incident. So follow-up activity is crucial. It's where you can reflect, document what happened, so it will be helpful in the future for further hardening your systems against that particular attack. It's always important to do the lessons learned. Document everything. Next, we have information security roles and responsibilities. A successful information security program relies on the shared responsibilities of many individuals within the organization. Every person in an organization needs to be very careful while accessing the internet or while accessing any kind of information on the network. Every person in an organization needs to be very careful while accessing the internet or accessing any kind of information on the network. Every person needs to be very aware that security is an ongoing process. Understanding the roles and responsibilities of those individuals and units who participate in the safeguarding of university information resources is essential. The roles and responsibilities in this document shall be reviewed for each individual to comprehensively understand their role and specific responsibilities in their environmental context. Finally, we have requirements of the policy. The policy must be consistent to be effective. The policy statement should be accessible. Issues should be clearly defined and when they apply to the policy. Define services such as email. Clearly define goals of the policy. Define expected privacy for users. If they have signed a policy agreement, they are supposed to abide by it, so they must read the policy statement carefully. So that concludes Class 2 of Course 2. In the next class, we will cover contingency and continuity planning. Thank you. This is now Class 3 of Course 2. In this class, we will cover contingency and continuity planning. So what is a contingency plan? A contingency plan is a course of action to help an organization respond effectively to a significant future event or situation that may or may not happen. It may happen, it may not happen, but your organization must be prepared nonetheless. A contingency plan is sometimes referred to as a Plan B because it can also be used as an alternative for action if expected results fail to materialize. So contingency planning is a component of business continuity, disaster recovery, and risk management. It's having a plan in place where we can recover data in case there's some form of disaster so we can make our business continue. What are the strategies for continuity? We have incident response plans, disaster recovery plans, and business continuity plans. IRP stands for Incident Response Plans. Disaster Recovery Plans, also shortened as DRP, and BCP stands for Business Continuity Plan. So, primary functions of the above plans are IRPs focus on immediate response if an attack escalates or is disastrous. Process changes to disaster recovery and business continuity plans. DRP typically focuses on restoring systems after disasters occur. As such, it is closely associated with PCBs. PCBs occur concurrently with DRPs when damages are major or long-term, requiring more than a simple restoration of information and information resources. Now we'll talk about continuity and contingency planning. Many company owners associate business continuity planning with disaster readiness. Even through fire, floods, and hurricanes pose significant risk to keeping businesses running, it's far more likely that companies will encounter challenges caused by more mundane and predictable events. The contingency planning process helps business leaders prepare for all kinds of worst-case scenarios, especially ones that will not make the evening news. But there must be a plan for any disaster scenario, and that will all be under continuity and contingency planning. So, what are the benefits of contingency and continuity planning? In most organizations, the planning process offers managers and owners insight into the changes necessary to optimize production, distribution, and customer service. Contingency planning also involves identifying the talent necessary to step into leadership roles in the sudden absence of top personnel. Teams also uncover alternate suppliers and business partners who can replicate the work done by existing vendors in the event of a work stoppage or another unexpected interruption. In case you don't have a contingency plan or continuity plan and some incident happens, how will you respond? Your work will be stopped and your business will cease to function. You need your business to run in a continuous manner, so this type of planning is vital. Next, we are on time frame. Effective planning sessions should be limited to a relatively short amount of time, but repeated on regular cycles to ensure the inclusion of new threats and considerations. Without clear limitations, some teams might feel compelled to explore every conceivable contingency at the expense of tweaking core business development plans. So continuity planning works well when implemented on a regular cycle, such as quarterly or semi-annually. Everything has to be updated. I'm talking about your applications, plans, policies, procedures, regulations. Everything must be updated regularly. There are always new threats. There are always new vulnerabilities, so everything should be updated on a regular cycle. Here are some things to consider. Most effective planning sessions include a neutral facilitator, such as an external consultant who can help keep parties on track. Many continuity planning facilitators recommend staging meetings off-site away from the usual pressures and distractions of the office. Continuity planning also offers a prime opportunity to force collaboration from team leaders who don't often get a chance to work together. Now we have disaster definition. Why are we talking about contingency planning? Because we can get any kind of disaster or attack at any time. So what is a disaster? A disaster is any event that can cause significant destruction in operational or computer processing capabilities for a period of time, which affects the operations of the business. The purpose of defining crisis or discontinuity is to establish a documented description of what constitutes a crisis or discontinuity. The intent is to minimize the decision-making process when an event occurs. So the purpose of defining a crisis or discontinuity is to establish a document that describes what needs to be done so that actions can be taken immediately instead of figuring out what to do, since it's all done ahead of time. Next, we have a graph that shows the percentage of organizations that have experienced some form of significant interruption and what happened. As you can see, the most common incident is a power outage. Following that, we have software problems, computer hardware problems, human error, some form of failure. Fires, floods, hurricanes, etc. are less likely to interrupt your business. However, all of these factors must be planned for and taken into consideration. However, it's important to note that a power outage is much likelier to affect your business. Next is data recovery. Once the extent of damage is determined, the recovery process can begin. When you have determined and responded to the incident, now you can recover the data. The process involves much more than a simple restoration of stolen and damaged or destroyed data files. Data recovery is the process of restoring data that has been lost, accidentally deleted, corrupted, or made inaccessible for any reason. An enterprise information technology or IT data recovery typically refers to the restoration of data to a desktop, laptop, server, or external storage system from a backup. Data is from a backup you have maintained, or you can use some recovery software. The disaster recovery scenario that will be specifically addressed within the scope of this plan is the loss of access to the computer center and the database processing capabilities. Although loss of access to the facility may be more probable, this disaster recovery plan will only address recovery of critical systems and essential communications. This means that you can't recover all the data, but you can recover the most critical and essential important information. This scenario also assumes that all equipment in the computer room is not salvageable and that all critical telecommunications capability has been lost. Next, we have a disaster recovery plan, or DR plan. So disaster recovery plan provides a structured approach for responding to unplanned incidents and threaten an IT infrastructure, which includes hardware, software, networks, processes, and people. Protecting your firm's ability to conduct business are the key reasons for implementing an IT disaster recovery plan. How a disaster recovery plan drives what you have to plan for, what kind of plan you have to have for disaster recovery, and how you recover, that sort of thing. Next, you can see how disaster recovery ties everything together. We have backup, monitoring, and redundancy. All of these tie into the disaster recovery plan. First, we have backup. Data that can be recovered in the event of a crisis. This should be secure and encrypted. Next, we have monitoring. We have to monitor our update data backup. Next, we have redundancy. You can't store your backups in one place. If you have your backups on premises, you run the risk of them being lost if there's a fire or a theft. These backups must be at least in 2 places, possibly 3. You can store them in the cloud on a separate facility. You can have one backup on-prem, but there has to be redundancy. Now we have finished Class 3 of Course 2, Contingency and Continuity Planning. In the next class, we will talk about password management. This is Class 4 in Course 2 of Security Essentials. And in this class, we will learn about password management. A password is the most common method for users to authenticate themselves when entering computer systems or websites. In a previous class, we discussed that passwords are an authentication method. It acts as a first line of defense against unauthorized access. By using authentication via a password, we can identify an authorized person trying to access a network or resource. It is therefore critical to maintain the effectiveness of this line of defense by rigorously practicing a good password management policy. The challenges of password management are that with the ever-increasing use of information technology in our daily lives, there are also an ever-increasing number of user accounts and passwords we have to remember and manage. You have accounts ranging from social media networks, banking, forums, etc. It's very difficult to manage all of these passwords at the same time. The choice of passwords used for different accounts presents a dilemma. On one hand, an intruder can gain access to all systems if the same password is used for accessing everything. On the other, it's challenging to remember a wide variety of passwords, which can lead to frustrations, lost time, and possibly lost accounts. This is a compromise. Nonetheless, there should be strong passwords in place. Now we have single passwords versus multiple passwords. From the user's perspective, memorizing one single password is much easier than managing multiple passwords, even if the single password is a complicated one. In addition, if only one password is enough to authenticate all systems, there is higher awareness among users in protecting their passwords. For systems that a user accesses only occasionally, it's quite possible for the user to forget a rarely used password. If you are using a single password for all of your accounts and then somebody cracks or guesses that password, they have access to all of your accounts, all of your information. So you need to know how to use multiple passwords for multiple accounts. It's more difficult, but multiple passwords are better than one single password because it's much harder for an intruder to get in that way. Now we'll talk about password cracking. Password cracking is the process of attempting to guess or crack passwords to gain access to a computer system or network. Crackers will generally use a variety of tools, scripts, or softwares to crack a system password. For example, using a rainbow table to brute force the password is one example of a technique that an attacker can use. The goal of the cracker is to ideally obtain the password for the root system or administrator. Password cracks work by comparing every encrypted dictionary words against entries in the system password file until a match is found. We basically have three techniques for cracking passwords. First, we have a dictionary approach, then a brute force, and third, we have guessing in the first part of dictionary approach. So basically, if your password is literally password, lowercase, nothing, that is very easy to guess and crack. Basically, like password, 1, 2, 3, 4, 5, all of those are often used. However, if you put in, for example, password, if you change your password to include a regular character, an uppercase character, a numeral, and a alphanumeric character. So you have a capital P @SSW0RD, for example. That is much more secure than password, lowercase. Having those different elements, a numeral, alphanumeric character, etc., is much harder to crack. So it's highly recommended that you change your passwords to include these hardening techniques. Next, we have password cracking for Windows. Windows password recovery tools are used to recover or reset lost user and administration passwords used to log on to Windows operating systems. Password recovery tools are often called password cracker tools because they are sometimes used to crack passwords by hackers. Legally cracking or unlocking your own Windows password is a legitimate practice. So getting into your own system is perfectly legal. You are technically cracking, but it's your password on a system that you own. So legally, you are in the clear. Now we're going to talk about Windows password cracking using Offcrack. The Offcrack Windows Password Cracker is by far the best free Windows password recovery tool available. It's a recovery tool basically, but most of the time crackers use this to crack passwords. It's fast and easy enough tool for a first-time Windows password cracker with a basic knowledge of Windows. Once the Offcrack program starts, it locates the Windows user accounts and proceeds to recover or crack all the passwords all automatically. Now we're going to talk about token-based authentication. The general concept behind token-based authentication is simple. It allows users to enter the username and password in order to obtain a token, which allows them to search a specific resource without using their username or password on a remote site. That's token-based authentication. Once the token has been obtained, a user can offer the token, which offers access to a specific resource for a time period to the remote site. So, for example, I will give you a token that you enter, and then you can access a resource on a remote site, and then after a certain period of time, the token will expire. It's ideal for temporary access to certain systems. Now we're going to talk about biometric-based authentication. Biometric verification is considered a subset of biometric authentication. Biometric authentication systems compare the current biometric data captured to stored, confirmed, authentic data in a database. If both samples of biometric data match, authentication is confirmed and access is granted. Biometrics are harder than passwords to crack. It is still possible, but obviously you can't brute force or guess a fingerprint or retina. Biometrics and passwords are often seen together as part of the two-factor authentication methods. You put in your password, then a biometric reading, and if both password and biometric match the ones in the database, then access is granted. Fingerprint recognition is one of the most well-known biometrics. Fingerprint recognition refers to the automated method of identifying or confirming the identity of an individual based on the comparison of two fingerprints. It is the most used biometric solution for authentication on computerized systems. A lot of devices these days can read fingerprints to unlock the device. Smartphones, laptops, tablets, etc. They have a small fingerprint reader in them, and you can use that to access the device just by your fingerprint. Next we have retina scan-based authentication. Retina scanning is the most accurate and secure biometric available, aside from DNA. It uses an image of an individual's retinal blood vessel pattern behind the eye as a unique identifying trait for access to secure installations. Retina scanners are used in many military bases, nuclear reactors, and other high-security locations due to their strength as a security measure. So typically, the closer to the brain security controls get, the stronger the security. So a fingerprint is relatively easy to lift and replicate, but a retina or iris scan is very hard to break because no two people have the same retinal pattern. A retinal scan is more secure than an iris scan, and an iris scan is much more secure than a fingerprint. So if you use a retinal scan, there is a very low false positive rate, and it's very, very hard for an intruder to break into that system. Next we have single sign-on, or SSO. Single sign-on is a session user authentication process that permits a user to enter one name and one password in order to access multiple applications. A good example of this is Google. Google implements single sign-on for their products like Gmail, YouTube, Google Analytics, so on. You only enter one password for these to access these products. So when you turn on your computer and access Gmail, you log in for the first time, and then if you go to YouTube, you will not need to enter your credentials again. It's all tied together. That is what single sign-on is. So what is single log out? Single logout is the process where you terminate the session of each application or service where a user is logged in. So again, Google does this as well. If you log out from Gmail, you are logged out from YouTube, etc. There may be up to 3 different layers of sessions for a user to single sign out. A session at an identity provider such as Google, Facebook, or an enterprise SAML identity provider, or a session at the auth 0 if the SSO flag is turned on. Next, we have single sign-on and radius. Single sign-on means the user will be authenticated by the company's own Windows domain or radius server within the LAN. When an SSO user connects to the VPN, Access My LAN forwards their username and password to the domain or radius server. The server will return an authorize or deny command to access My LAN, and based on this, the user will be allowed or denied access to the VPN. We have finished Course 4, Password Management. In the next class, we will talk about incident handling. Thank you.